Okay, I'm Adam Winch again with Defenders USA. Russell and I are going to be talking about some of the different rifles we got here and all sorts of different things he wants to talk about. So, Russell, go for it.
All right, well, obviously in the long-range precision shooting world, there are several different types of things. Some rifles for hunting, some semi-automatic, quick target engagements, you can shoot real fast. Chassis guns like this, Ruger Precision, it's 338 Lapua Magnum from Savage Arms. Obviously, each one of these things has a bit of a different purpose. And for the sake of just talking about what long-range shooting is in a very basic sense, it's difficult to get into many of the specifics. Obviously, the one closest to the camera is a 1975 model Winchester 670 and 243. It's my dad's hunting rifle. He's used that thing for years. That thing's a great choice. It's an accurate rifle. Second one here is an AR-10. That one belongs to Adam. You saw that in another video. That one's really fun to be able to do all kinds of fun stuff. It's capable of 1,000 yards all day long. 6.5 Creedmoor right here, 1,500, even out past that, you can probably get a mile with it. The 338 Lapua is going to get you well beyond a mile, probably out to 2,500 yards, 2,500 meters, something like that. So there's so many different things that can go into long-range shooting. And long-range shooting is more of a science than it is anything else. The factors involved with long-range shooting include meteorology, algebra, calculus, trigonometry, so on and so forth. There's a lot of things that go on in there. I've got a few lists of things that I wanted to go over, different loadouts and so on and so forth. Without knowing exactly where to go in such a short period of time, it's difficult to get into things.
Yeah, that's one of the issues with this type of thing is, I mean, one, it's a large investment, right? To just get into long-range shooting or even sniping or whatever, it's a very expensive proposition, right? So we want to make sure that whatever you do pick, you get the proper type of gun from the very beginning, so you're not having to piece things together back and forth and then buy the wrong caliber for your purposes, whatever else. So we want to make sure that whatever we help with today, if you're looking at getting in this type of thing or eventually buying something like this, that you buy the right gun for your right purposes.
Exactly, and if you're gonna stick with hunting, you don't have to spend thousands and thousands and thousands of dollars. That 243 all in is somewhere around a $500 setup.
And that includes the scope.
That
right?
includes the scope and the bipod, and it's very, very accurate within the ranges that you would take an ethical shot on an animal. My dad has hunted deer with that thing for years and never took a shot beyond 300 yards and always came home with his animal. So it's perfectly fine for that. Is it going to replace what this 338 Lapua Magnum does at 2,000 meters? Absolutely not. So considering where you want to go in this sport is really going to determine where you go with the rifles. Should you get all of them? This is America. Absolutely. Get them all. But it's difficult to tie one thing down and say one is better than the other when there's so many different facets to this type of sport.
You know, personally, I have this little 308 right here. I mean, it's just a tack driver at 1,000 yards. But honestly, this thing can go out to 1,500 yards with the right type of loads, knowing what you're doing. I mean, it's an easy gun to go there. We've even taken guns like these and taken them out to 2,000 yards. So depending on what you want to do, I mean, I personally like the AR type of platform, right, from the military and the police world. It's very replicable compared to what I would use for my home defense gun or just my play gun on the range. So I like that. But at the same time, you might get a little tighter accuracy out of a bolt type of gun that's out there. A little bit slower, but not by a whole lot. And these are great guns too. So to me personally, I like the semi-automatic platform that's there. And though I've trained with and used a lot of these bolt guns, to me that's just faster and a little bit less work.
And expounding on the accuracy inherent with a bolt gun over a semi-auto, that has to do with the type of lockup with the bolt carrier group in an AR type platform or semi-automatic platform. It's usually an inconsistent lockup in the barrel extension, which changes some things as far as where the round is in the chamber, distance from the projectile to the throat and to the beginning of the lands, and so on and so forth. And that can throw off accuracy. It is possible to spend a lot of money and get a matched bolt and a matched barrel, and that will drastically increase the accuracy of a semi-automatic platform. A bolt gun has a more consistent lockup. Generally, just about any manufacturer does a pretty good job of tightening up the tolerances in there, so you get a consistent lockup every time you run the bolt and put a round in the chamber. There's a whole lot of variables, as I was saying before, when it comes to long-range shooting. We teach a class that all in all, it's almost 200 hours worth of instruction time when we get through every bit and piece of all the variables and the way to control all of those. And we're not obviously going to do that here, so we'll just talk about some of the things.
Yeah, let's get into the constants of things and the variables of these.
And I got to go with my notes here because this is kind of a very, very condensed version.
We're going very fast here.
So as far as constants with ammunition, the only real constants with the ammunition that you have are the projectile weight. Sometimes, depending on your manufacturer, if you're reloading your own and go through somebody who makes a solid copper monolithic, you're going to have a better chance of the weight of each projectile being more consistent from one projectile to another. Factory ammunition off the shelf, especially like a soft point with exposed lead, it's not always going to be the same weight. And the other constant, which sometimes is a constant, sometimes it's not, is the profile of the projectile. Again, with a soft point, you could have deformations in the lead that's exposed, and it's not the exact same profile down to the 10th of the thousandth.
So when you say deformations, maybe that's been nicked in some way, shape, or form as you put it in your magazine or put it in the bolt gun or something like that, or got nicked somewhere else, and now that slightly changes things because that soft metal has been deformed somehow.
Right, and even with your match grade bullets, you look at a Sierra Match King, if you reload and you pull several projectiles out of the little green Sierra box or whatever, and you get real close and look at the tip of those, you'll see that not all of them are the same. Does that matter? Some say yes, some say no. Depends on what kind of distance you're going and what kind of tolerances you're calling acceptable. As far as the variables of the ammunition, there's tip damage, there's jacket inconsistencies. The center of gravity could be different in the way they swedged the jacket around the lead. The seating depth, is your manufacturer making sure that the seating depth is the same consistently throughout? This is, again, for factory ammunition, not reloading. You have a little bit more control over it when you're reloading your own. The powder charge, I'm sure everybody's heard of a squib load. If not, it's basically when a round doesn't fire as it should and a bullet gets lodged somewhere in the barrel. That's obviously from several things that are variables in the manufacturing of the ammunition. Powder burn rates. Powder burn rates can change based off temperature, based off the granule size of the powder. So many different things. The age of the ammunition could change all of that. The primer ignition. Sometimes primers don't ignite the powder fully and goes back to the burn rate. It doesn't ignite properly. Could cause some problems, but it could cause some inconsistencies. And you may think that you had a perfectly good shot and you got a miss for no reason and you don't know why. It could be one of these things. Case dimensions. Factory ammunition could have good or bad case dimensions. Everybody's got their favorite brand of ammunition, and typically they have a reason for it, whether it's the consistency or the accuracy or whatever the case may be.
And in this case, Black Hills actually, for a gun and a girl, Black Hills actually did their best to get you guys a really good rate on their ammo for the course that we were going to do out here. And Black Hills, if you know that type of ammo, they make some really high quality ammo.
Absolutely.
I mean, it's so high quality that the military depends on it. Our snipers do. It's just really good stuff out there. So when you're looking for good consistency across the board, they're well known for it. And of course, they stepped up and did good things for a gun and a girl for this year too. So just an idea, maybe support Black Hills.
Absolutely. Another variable is the stabilization factor. Now, a lot of people would think that's a constant because it's the gyroscopic stabilization of the round during the external ballistics phase of things. But that is also a variable based on temperature, based on humidity, based on all kinds of other stuff. As your muzzle velocities change due to burn rate change, due to temperature change, the stabilization factor can change. The max ordinate of the round, depending on what range that you're shooting at, the max ordinate can change.
So when he says max ordinate, we're talking the height of the round after it's exit the barrels as it goes up, right, until it eventually comes back down.
The highest point of the trajectory of the bullet is called the max ordinate. And depending on what range you're shooting, a general rule of thumb is the max ordinate is about 60% of the range to the target that you're shooting at. But things like that can change. Now, if you're shooting extreme long range, your max ordinate might be 100 feet above your line of sight. and the wind can affect the bullet at different points of the trajectory, especially up at the max ordinate.
And the further out you go, I mean, wind oftentimes has different slipstreams, right? Near the rifle itself, it might be going one way. Another halfway out to your target, wherever that is, maybe going a completely different direction, where somewhere else it might be slipping another different way. So you got to learn to read the wind. I mean, when it comes down to it, reading the wind is one of the biggest portions of being able to do long-range shooting well.
It's probably the hardest skill to attain and the most important. And a lot of people think that throwing money at a rifle is going to make them inherently accurate, and that's not the case. The biggest thing in long-range shooting, most rifles will outshoot the shooter. The biggest thing is the shooter. The shooter's ability to be able to compensate for all of these variables is going to increase hit probabilities at different ranges. More on ammunition variables is the trajectory. The trajectory can change for a number of factors. If you're shooting high angle targets, whether uphill, down towards a target greater than 1,000 yards, you could be shooting between two different barometric pressure zones. So it may be 25 inches of mercury where you're shooting from, and you're shooting down into another area, which could be 26 inches of mercury. Taking that into account, it changes the drag function of the bullet.
And then ultimately the point of impact of the bullet itself.
Exactly.
So you got to learn to aim differently, which we won't get into high angle shooting at this point, but I mean, that is one of the big variables to this.
And the last thing that I could kind of come up with real quickly for an ammunition variable is the ballistic coefficient. Sierra does a really good job of listing their ballistic coefficient based on velocities. Some manufacturers just put out a G1 ballistic coefficient of a certain number. And that changes. The ballistic coefficient has to do with how well the round kind of fights the wind, as well as how well it retains its velocity. As the velocity changes, the ballistic coefficient changes, and as you know, the bullet gets slower after it leaves the barrel. It only slows down from there. After ammunition, we come to the rifle. The constants in a rifle, you may think everything on these rifles is going to be 100% the same all the time, but that's not exactly the case. The barrel length will always be the same. As long as you don't change barrels, your barrel length will always be your barrel length. The twist rate will always remain the same. The optic mount height, the height over bore from the center of the action to the center of the optic, that shouldn't change during normal day-to-day activity or use of the rifle. And as far as first focal plane scopes, one constant that you'll always have is the MIL or the MOA target relation or correction. So as you call misses, or if you see that you've missed, you can use the scale in your first focal plane rifle scope to see about how far off you are. Some people will say you can do it with a second focal plane too. Yes, you can at their calibrated zoom if their tolerances are tight enough that that calibrated zoom is exact. Some of them are, some of them are not.
So let me go back to some of the constants with rifles, okay? So jumping back a few steps,
Yeah.
right? One of the constants on this changes if your rifle is not truly torqued down well to spec. We get a lot of guys and girls that show up to our courses here, some of our long-range courses, and they come in thinking their rifle's all good, right? They've been shooting for a long time or whatever it may be. It's a brand new rifle. But then we find out because all the parts and pieces of this rifle that need to be torqued down properly, locked in well, aren't, and then suddenly their rounds are all over the place. When we finally sit down and one of our mechanical guys, Russell or somebody else, gets on the gun and really works it over and torques it down correctly, then suddenly the rifle becomes a constant, right? Where before, if it's not torqued correctly, so it needs to be done well, torqued well. If you have a rifle like this, it's probably a good idea to either learn the specs on this and learn how to do that, or take it to a really good gunsmith, right? And there's a lot of gunsmiths out there, and not all of them are that good. Some are. You got to find a really good gunsmith who understands your rifle well and really get everything torqued down well.
Okay, so with that being said, with the constants of the rifle, rifle variables, the bore condition, it's not always going to be the same. A brand new barrel shoots differently than a well-seasoned barrel, which shoots differently than a cold barrel or a hot barrel or a dirty barrel that has all kinds of chemical fouling or the carbon from the powder burn. The bore wear or the barrel life can change things. As a barrel kind of nears the end of its life and starts to open up a little bit, velocities can change, accuracy can change, all kinds of things can change. So the barrel is not a constant other than the length and the twist rate. Eventually you'll burn through a barrel and you'll have to replace it.
So let's say this, okay? This is a pretty brand new 308 with a, 18-inch barrel here, okay? What would be the barrel life on something like this?
Generally with something like that, being a 308, which is kind of a nice round when it comes to barrels, that also being a stainless steel barrel, I know on mine, I'm not seeing any accuracy differences or shifts in point of impact on my 18-inch, which has got well over 1,500 rounds through it. My 24-inch 308 has close to 3,000 rounds through it, and I'm seeing everything still working. So the hotter the round, the faster the round. Magnums for like this 338 Lapua are going to be a little bit harder on the barrel.
So ideally, the idea behind this is this 308 actually has a pretty long barrel life compared to a lot of other stuff.
Yeah.
You take this 6.5, right? It's a much harder, hotter round in a sense.
Yeah.
It tears down this barrel a lot sooner than it will that 308. Even this 338 Lapua is going to just eventually tear this barrel up far faster, right? Losing tightness within its shot group simply because of the barrel life to it. So part of the reasons I went with this, a lot of people tell you the 308 still is an archaic round nowadays with the 6.5. I just enjoy it. It's what I've used all the time, right?
And it's
but
a
it
tried
also
and tested round.
Yeah, but also I can spend a lot less money ultimately to still have the same type of impacts that I wanted because the barrel life is longer. Great gun right here, great caliber on a 6.5, but the barrel does wear down quickly. Great gun here too, good caliber, wears down very, very fast. So you're having to replace barrels, which ultimately changes all sorts of things as you respun up both your dope, get to know the rifle, the harmonics, everything.
So next we come to barrel temperature. Obviously the barrel temperature is going to have an effect on your point of impact. As the barrel gets hot, you run a whole bunch of rounds through the gun. You get what's called barrel droop, and it does change a little bit. The barrel will deflect slightly. So that can change things, and that can change minute by minute, hour by hour, day by day, obviously.
Based on the heat that you're in, right? The sun,
the heat,
how much rounds you've put through this. If you heat up your barrel, different things like that.
Right. Chamber temperature. Now, I chose to separate chamber temperature from barrel temperature for a very specific reason. So with this AR-10, obviously a semi-automatic, we run 19 out of 20 rounds through this thing really quickly. And on the 20th round, it chambers in there on a day that's 60 degrees with, say, 25 inches of mercury. Ammo temperature was 60 degrees. And now we let this thing set for a minute or two with that one round sitting in the chamber. It's going to cook that round, and now the muzzle velocity is going to change because there's going to be more energy in the powder due to the rise in temperature. So that's a variable that you've got to consider.
And a variable can go throughout the day. Right here in Colorado, we're sitting at 6,400 feet on this range right here. Right in the morning, it could be very, very cold compared to the afternoon. Right in the afternoon, like it is starting to be now. I mean, I'm starting to sweat under this long sleeve shirt. Where this morning, I mean, it was frigid. It was quite
about
cold.
40 degrees when we started.
So that temperature change has a real effect throughout the day as you shoot this gun from colder weather to hotter weather as it dips back down in the evening. So I mean, the part of the variances are the temperature of the outside environment itself.
Absolutely. So I put ammunition seating depth again on the rifle, you know, the distance to the beginning of the rifling. That's one that could have stuck with the ammunition side of things, but on some rounds you can have an issue when chambering around if your neck isn't crimped or something like that. And you go to chamber around, you might disturb the way the bullet sits in the case. It might push it back a little bit or something like that, and it can cause some issues for the accuracy, something that you may not catch, something that you may not see. It's possible to do it with a semi-automatic that's happening quite quickly, and obviously chambering the round for you. Harmonics. Harmonics is a big one to get into, and it's super difficult to try to narrow it down for a brief video. But basically what I'm going to talk about here is obviously with the first two rifles, the 243 and the 308, we just have regular barrels. Now the 243 has that sight on there, which doesn't change the harmonics from one day to another. It just is what it is, but it's going to have a different harmonic than the 308 that has nothing on there. The muzzle brakes can change the harmonics as they gum up, and the gas flow is slightly different.
So define for us harmonics. What do you mean?
So the harmonics is when you set off a round in the gun is going to vibrate. There's going to be nodes and antinodes. The nodes are going to be the solid points where there's next to no movement. The antinodes are going to be where the most deflection is. So depending on where things happen, this is a 24.5-inch barrel without the suppressor or the compensator on here, but I haven't measured that, so I don't know exactly what that is. But as the barrel whips, and this particular muzzle device vents gases sideways and up, and what that does is it kind of pins the harmonics a little bit and changes where the antinode is in its maximum deflection. By taking this off, I could have a completely different characteristic in the way that this barrel vibrates. When we talk reloading, people are talking about tuning their ammunition for accuracy. And what they're doing is they're not necessarily trying to build the hottest round that they can build. What they're doing is timing the exit of the round to match the certain point of the barrel whip during the harmonics, to where the antinode is closer to the axis of the bore. It's not so much deflection during the vibration of the harmonics. Suppressors can even change the harmonics as the temperature of the barrel increases. Rapid fire. You can change the properties of the metal of the barrel, and you can get different harmonics throughout the day, throughout a certain stream of fire, so on and so forth.
So basically you're just saying how the rifle moves after the explosion of the shot.
Right.
Even as the round is exiting the barrel, right? Going from 0 to 100 gazillion miles an hour as it comes out, just how the rifle itself moves.
Yes.
Okay.
Yes. Another thing that's kind of a variable, this Winchester here, like I said, is an old rifle. Now, there's a thing called bedding the action, which has to do with disassembly of the gun and using fiberglass and other compounds to tighten up where the recoil lug of the action sits in the wood stock. So this particular wood stock, as everybody understands with wood, it absorbs moisture. So on a humid day, that stock can actually change dimensions slightly. In doing so, it can throw off accuracy, point of aim, point of impact. By bedding a wood stock, even some fiberglass stocks, you can do this bedding process on there and really tighten up the action to stock clearances and increase your accuracy that way. With that, like this Ruger Precision is a chassis gun, and it's got a free-floated barrel just like the AR, just like this one. That means that there is nothing touching the barrel after the barrel nut or the method of attachment to the action itself, which allows the barrel to do what it does and vibrate freely. And then you can tune by either cartridge selection or hand loading to get the harmonics under control to where you can predict the point of impact accurately. Rifle support is another variable. Things can change. Now, earlier we did a video of the sandsock. The sandsock, by having something soft, you can dampen the vibrations. Even having a bipod sitting on a concrete table or a concrete slab on the ground, proned out, something like that, those hard surfaces can amplify the vibration of the harmonics.
Meaning as the shock wave goes through the gun down into whatever else it is and bounces back up, versus maybe if this bipod was up and it was sitting on, say, a sandbag or something that's softer, it absorbs the harmonics.
And that adds to a more repeatable shot. So yes, bipods are a form of artificial support. They're great, but they do have an effect as opposed to putting something soft under the front of the gun.
What I've done oftentimes with mine is I'll just take one of my sandbags. I got like brute force sandbags or something like that for exercising with, and I'll just throw it on there on the front with the bipod up, right? So I fold it up and then just lay it on there, and then in the back a sand sock of some type, and mine's made of rice and beans, just a sand sock that I can hold and manipulate back and forth with my non-dominant hand under the buttstock so I can raise and level it. And between that soft sandbag to the front, somewhat soft, and the somewhat soft sandbag to the back, I mean, that's what the rifle's resting on. That takes away a lot of the vibration of the gun in the shot, and
it's like
helps.
Suspension on your car.
Yeah,
I mean,
it helps.
Good soft, like the ride of the Cadillac being super soft, stuff like that, versus super stiff suspension that rattles your teeth out when you're going down the road.
It just helps ultimately as you shoot the gun and point of aim, point of impact.
Absolutely. So natural point of aim and the rifle shifting on recoil. We kind of touched on that a little bit in an earlier video down when we were at the 100-yard range. That's a variable that has to be accounted for. That's one of the things that we go over in our class. We spend an extensive amount of time working on body position and the natural point of aim.
Learning how to get really, really comfortable behind that rifle,
Right.
to the point where when you lay down on that stock and you're looking through your reticle, that you could literally, if you had to, let your air out, right? Get your reticle lined up to where you could even just fall asleep on that type of thing. As soon as you open your eyes back up, you're right there on target, because it's truly a natural resting point to where your body doesn't feel cranked off to one side or the other. Your neck feels off. I mean, if you get away from a rifle that you've been laying behind, we do most of our stuff generally from prone. If you're going prone on a rifle and you spend time prone behind a rifle, if you're not set up well, you're going to realize you're going to be extremely sore.
Absolutely.
If not right after, but certainly the next day or two. So you want to be able to get set up well in a good base platform to where, one, you're comfortable behind it. It's almost like laying on a somewhat hard pillow, but you are comfortable in there. You could stay there for hours if you had to.
And on that, a military sniper may have to go somewhere, and they may have to be on station for days at a time. So early fatigue could compromise their entire mission. So this is something, it goes into sport shooting. It goes into long-range hunting. If you know you're going to expect your animal somewhere to pop out in that area in front of you, you don't want to be fatigued. You don't want to have eye fatigue behind the scope. You don't want to be, struggling, and then when that big moment pops up and your animal pops out, you're in the wrong position behind the rifle. You get some scope shadow, you've got something like that, and you throw a miss. So that particular subject right there at the beginning of our courses is something that we cover that about an hour, more than this video that runs through so much more information is going to take.
Well, to talk about that, I mean, we found with a lot of shooters, if you're not a really good shooter, or it's hard for you, you're inconsistent with your point, your impacts. Oftentimes it's your setup, it's your base, right? How well are you set up behind the rifle? Are you in line? Is it comfortable? Have you fully spread onto the ground as much as your body can be? So things like that. I mean, it's a truly big thing to be able to hit well for you to learn how to truly be comfortable behind a rifle. And oftentimes you'll take a new shooter who's never done this before, and it'll take them a day or two to finally find that truly comfortable position, right? We'll get them almost all the way there, but then their body will learn to sink into it. But once you get your body, you learn to get your body set, and now you can do it in almost any position and learn how to do it well. But that body setup behind the gun truly makes the difference, I find, with a novice shooter to an expert shooter.
Absolutely. A few more points on variables of the rifle. Turret repeatability. So if you are going to dial your elevation, whether it's mils or MOA, we can get into that in another video. But if you're going to dial that, you want those to actually mean what they're supposed to mean. When you buy a scope that's a clicker type or target type scope that has the exposed turrets, you definitely want to be able to have something that replicates over and over and over and over again. If it doesn't, you may think that you're going to dial your elevation 10.7 mils for 1,000 yards, and it went 10.9 mils worth of movement, or 10.5, or something like that, and you could have a miss because of the inconsistency of the manufacturing of the scope. And that's why some scopes cost a whole lot of money. It's not just glass, it's the erector assembly and the turrets being repeatable. Now again, back to the reticle, one of the variables, if you have a second focal plane scope that has a calibrated zoom, if the manufacturing tolerances are perfect and you can hit that calibrated zoom perfect every single time, then the reticle has the same values as say a first focal plane would. But if, and we've seen it in courses where people were trying to judge distance, mill the target as we call it, using simple math and relationships in the reticle to the target size, they can judge distance. If they forgot to put their scope back on the calibrated zoom or wherever it is, they get the numbers way off. And if you're alone and you're, again, going to hunt that big trophy buck, and you have a second focal plane scope and your rangefinder batteries died or something like that, it's a backup method to be able to do it. But if you do it wrong, you could miss by a mile.
Where with a first focal plane, completely different.
Absolutely. That's going to be a relation that stays together every single time. The last thing that sums up kind of everything on rifle variables is the shooter. It's you. If anything you are doing is incorrect or inconsistent or something like that, it's going to affect accuracy from shot to shot, from day to day, from week to week, from month to month. So that's kind of where we come in as instructors, is we want to mitigate all of these variables. And again, we've got 200 hours worth of instruction to cover all of these different variables.
Not that you would go through if you came in as a beginning student with us or just wanted to start going through this. You're going to do all 200 hours right then and there, right?
It's divided.
It's a progression of courses, but what Russell's saying is completely correct. I mean, the biggest thing you can invest in, like you're going to hear, probably is the theme throughout A Gun and a Girl every time you go to this from year to year. Is training, right? The biggest thing you can invest in is, I mean, buy all the crap you want, put it on the rifle, you know, make the rifle the greatest thing in the world. But honestly, it doesn't matter how good the rifle is, how good the equipment is, if your training is not good, right? If you can spend the time to truly dial you in as a shooter and become consistent with it, no matter what the weather is like, the platform that you're on, no matter what you do, if you can build the proper shooting habits and proper shooting, I guess, the way you set up with this, I mean, you can shoot to the degree that this rifle could shoot,
it's
right?
Consistency.
Yeah, it's consistency, and that comes through good critical training or good thoughtful training that's there. So that's what we do. If we can get you out here to these type of courses to where we can just build that consistency, one, know how to do this well, right?
Yeah.
Understand all the stuff that we're barely just brushing the surface on. And I know it's kind of boring, I mean, it's technical talk, but I mean, once we build this in a fun course, an interesting course, then we build in the proper habits and the setup for you as the shooter. I mean, it's amazing how you can take the person who's never shot beyond 400 yards or 500 or 700 or 200 yards, and within a day we'll have them to 1,500 or further yards, and they'll be consistent with it, no matter what the caliber, from a 308 to further. I mean, and hitting over and over. So the biggest thing you can invest in is becoming a consistently good shooter with proper shooting habits, whether it's for long range precision, I don't know,
pistols, carbines,
whatever it may be. If we can build that into you, I mean, that's what's going to make you the shooter.
Absolutely. So, real quick before we kind of wrap this up, I've got some environmental constants, and there's only a few. Things can change second by second when we talk environmental conditions. The only things that are constant, one is gravity and two is Coriolis effect. So there is some incredibly confusing math when it comes into calculating Coriolis effect, and I'm not going to get into that, but it is some pretty neat math. But the gravity, if you're a metric guy, 9.8 meters per second squared. If you're, you know, like the rest of us and like the English system, 32 feet per second per second.
A gun and a girl.
Understood. You're a lot smarter than we are generally.
Yeah.
Generally, we're both married. We know
so
that.
if you're a gun girl.
Gotcha. Okay. So, environmental variables: temperature, humidity, barometric pressure. Again, shooting through different barometric pressure zones. Density, altitude. These things change all the time. Mirage can throw off where you think your target is. Looking through your optic, you could think you're looking right at it, but due to mirage, it has shifted slightly. Just as the way the light bends through different densities of air, which is exactly what mirage is. Wind speed and direction, that can change second by second, and it's very difficult. That, again, is one of the hardest things to do when talking long-range shooting, especially long-range shooting beyond 1,000.
We were out here shooting the other day, just testing this rifle out, and we were shooting out to 1,000. I was shooting a string of 10, and it was just ding, 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 hitting the thing. And all of a sudden, I watched the wind change just as I was beginning to pull the trigger. And by the time the trigger broke, the wind had completely changed from the shot maybe 3 seconds before, 4 seconds before. And by the time the round got there, that wind had taken it completely off from where it was before. I mean, wind can change just like that. And once you learn to read the wind, right, especially when you learn to read mirage, everything else, I mean, it just makes it cool.
And just for the heck of it, I mean, the time of flight on a 308 round out there, I thought I had it written here, it's more than a second. I mean, so when the wind call is made and you're confident in what that wind call is, and you send one out to 1,000 or beyond, your time of flight comes into play. What's that wind going to do 3 seconds? Nobody can predict the future. So it's fun, but it's difficult. Direction of fire. I mean, you may be thinking you're going to be shooting due north and your deer pops out behind you and now you're shooting south. So a lot of things change in your environment based on the direction of fire. Your angle of fire, whether you're shooting uphill or whether you're shooting downhill. Again, we get into some pretty cool math, cosines of angles and stuff like that when we're correcting for actual range and horizontal range, and what gravity effects are on the bullet when you're shooting uphill or downhill.
So let me jump in here for a second, right? Russell here, he's like a genius, right? A little kid, he was doing stuff adults don't do. I mean, in engineering type things. I mean, it's amazing what this guy knows. Me, I'm just a normal everyday Joe, right? I don't understand all the math and everything else. I can shoot, I can hit stuff, and when I sit down and spend time thinking about it, it's pretty good. So when you're hearing all these different highfalutin words coming out of this guy, because he's just smart like that, right? Don't let that scare you off from a good gun course somewhere, whether it's ours or some of the other good ones that are out there, right? Yeah, there's a lot of math, a lot of different cosines and all sorts of other words out there. Actually, once you get going with this, it becomes pretty simple. And I mean, to me, even I can understand it. If I can understand that, anybody can.
And that's you know, the nature of our course. You know, this is a very brief overview, hopefully to pique your interest, or at least give you a direction of where to look to see how far down this rabbit hole goes, because it can go very, 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 very far. There's so many different things from like I said, meteorology, to physics, to calculus, algebra, trigonometry, so on and so forth. When you are using things like a theodolite to, you know, range a target, which is something similar to a mill reticle or something like that, it can get pretty carried away. We like to teach things, both the old school and the new school method. I have a weather flow Bluetooth weather meter, an anemometer, so I can get wind speed and direction. I can get the barometric pressure, so on and so forth, and I can use these to calculate, you know, final firing solutions. If you really want to get first round impacts at long ranges, some people argue about what a long range is, and I'll tell you that a first round impact at 600 yards for experienced shooters who do this professionally is pretty easy. But for somebody who doesn't do this professionally, getting a first round impact at 600 yards could be a massive accomplishment. And what we do is we try to get people to have 100% confidence in a first round impact out to 1,000 yards, despite weather conditions, despite wind conditions, so on and so forth.
And that's the ultimate goal here, right?
Right.
I mean, we're looking at just from the standpoint of an everyday person to literally the professional gun user of some type, like our SWAT guys or
Right.
our special operations snipers or something like that, right? I mean, you want to be able to, if you get down behind a rifle, if you had to make a 1,000-yard shot to a standard human silhouette, you could make that, right? And if you can do that pretty easily on first round consistently every time, right? If you're in PRS or some of the other competition stuff, you can do that stuff pretty easily too. I mean, that's the whole hope with good training and good equipment, is that you can make your consistent shots that you need to make every time, and then repeatable, right? And you can even tighten it up more and more and more as you understand it.
Absolutely. And full disclosure, the kind of course that we teach is kind of in line with the military law enforcement kind of thing. I don't know the rules to all the competition shooting sports out there, so I don't try to teach that. Does accuracy with a rifle transcend any genre of this stuff? Absolutely. So what we teach, we teach shooting from the prone position mostly. We do stuff from different positions, but where PRS, they have different obstacles and they're timed. They're using holdovers in their reticle. I mean, some of these guys are some stellar shooters. They're doing some really cool stuff.
Which we ultimately get into after our beginning courses.
Yeah, the beginning
we get into
courses are
those
the
unconventional
introductions.
positions, right? High angle shooting, all, you know, unknown distance, shooting with other people, I mean, tactics, you name it. I come from the law enforcement, the military world, so we look at it from that perspective, and it just makes it easier for us because we've just never been competition shooters, but we're finding that everything we're teaching, as we get competition shooters come to our courses, that they're able to take it away and use it very well in their competition courses. We had a Navy SEAL guy who
Right.
came to one of our, actually a couple of them, and he used a lot of this in his competition shooting, and he's let us know several times that his competition stuff has gone even further through the roof,
Right.
just based on a lot that we were using.
Yeah. Well, I think that about wraps it up for a, shall we say, brief little video of an introduction to kind of long-range shooting. If they want more, they can.
Well, we'll get you some more here, but thanks for your time. I know it's kind of technical, and we just kind of really touched on variables and constants of rifles, and I mean, this is all new to us all, right? This whole video thing, COVID-19. I mean, this is not the way we usually do things, so this is kind of different for us. Hopefully it wasn't boring for you. Hopefully there's some good information in here, and we're going to try to get some more out and keep them as fun as we possibly can as we're learning how to do this ourselves.
All right.
Sounds good.
Outstanding. Thank you.